All right, greetings, YouTube. This is Beautiful Mind coming here with a few questions. We have an exam coming up next couple of days, so let's just take a look and see what came in. So this first one comes from Precalculus, and we're asked to find the exact value of y or state that y is undefined. Okay, so let's take a look at it now. Now we're dealing with inverse trig functions. So we have inverse tan of tan. Now usually an inverse f of x they cancel and it's just x. But for the inverse trig functions is a bit different. So we're going to start with a quick sketch of tan of theta. So now if we're looking at tan of theta, tan is 0 at the origin. After 90 degrees, I think tan is undefined. At negative 90 degrees, tan is undefined, and tan is an increasing function, so it kind of has this pattern. And it continues this pattern going to the left and right, so when you get to 180, you're back at 0, and then at 270, you have an asymptote. Again, all the asymptotes for tan occur at the odd multiples of pi over 2. So that's 1 pi over 2, 3 pi over 2, 5 pi over 2, so on and so on, or odd multiples of 90 degrees. So now, to talk about inverse trig functions, the trig function has to pass the horizontal line test. So if we looked at the whole trig function, it would fail the horizontal line test because it goes on forever and left to right. So we impose restrictions on the original trig function so that we can talk about inverses. So tan, for instance, tan of theta, we restrict the domain to negative 90 to 90. Okay? And we do parentheses because of the asymptotes. And the range, looking at this graph, is all reals. Okay? So then when we talk about inverse tan, we'll say of y, then this is now our range and this is our domain. Okay? So now when we're doing the inverse trig of the original trig, from this question 4527, if our theta were between was in our original domain, then it can cancel and we can just take it as is. But because theta is not between negative 90 to 90, let's see what angle are we really talking about here. So if we have 4 pi by 5, let me see if I can just pull up my calculator. Alright, let's see if it works. There we go. So I'm going to reload it. Alright. So now, let's convert this radian to degrees. So I would just say the 4 pi by 5, I'm going to multiply it by 180 over pi. And we'll get 144 degrees. So I'll say times 180 over pi. Radians are going to cancel, and we're left with 144 degrees. Now, so for tan, our theta has to be between negative 90 and 90, but we're at 144 degrees. So we have to be either in quadrant 1 or quadrant 4. Now we need to find the reference angle. So now 144 is how many degrees away from the x-axis? So let's pull up our calculator. So now 144 we see is in quadrant 2, so we're going to say 180 minus 144 to see how far away from the x-axis we are. So the reference angles is saying that we need to be 36 degrees away from the x-axis. We got to decide if it's quadrant 1 or quadrant 4. Okay. I would say it would be quadrant 4 because tan has a negative slope in quadrant 2, and since we want our tan to have a negative slope, that means we need to be in quadrant 4. So that means we just convert the negative 36 degrees and convert it to radians. So then what I'm going to do is say times pi over 180. Degrees are going to cancel. And so if we say 36 divided by 180 as a fraction, we get a negative pi by 5. Okay? So that's the best explanation I can give as to where that answer comes from. Okay. Let's try another one. So now in section 4.5, question number 33, it says find the exact value of this expression. It's probably a good idea to go ahead and identify the domain or range of this. So now for this one, I use, because it's the reciprocal of cosine, so I'll start with cosine of theta. Whenever I do the reciprocal functions, I'll go cosine of theta. Now, I know we restrict cosine from 0, so the graph of cosine, we do this, all right? This is our 90 degrees, and this is our 180. And so it goes from 1 to -1. Now, so cosine we restrict as such. Okay. So now cosine, we would normally say the domain would go from 0 to 180, you know, and the range would be from -1 to 1, right? But we want the reciprocal, so we're gonna, so secant, it shares the max and the mins, and all of our zeros become asymptotes. So that means the graph of our secant function, so secant of theta, is going to look something like this. So say this was 1 here, and this was -1. And then we still had our 90 degrees and our 180 degrees. I just kind of changed the window a bit. So they're gonna share the same max and the same min, okay? But that 0 turns into an asymptote, so this is going to be an asymptote there. And then it's going to go like this, and this is going to go like that, okay? So then we see for a secant of theta, the domain, so the left to the right is going to go from, we go from 0 to 90 degrees, union, and let's move this down some. (90° to 180). Okay, and the range we see goes from -infinity up to -1, union 1 to infinity. So now I will give you this kind of stuff on the exam, but you still want to know how to do this, because I can give it to you. If you don't know what you're doing, it's not going to help, which is very easy with this kind of topic. So you have to really push to understand. So now that we have restrictions on our domain and range, we can talk about inverse secant. Okay, so that means that this is going to be our range, this is going to be our domain. All right. So now when we okay, so if we're doing inverse secant of -√2, that's a number that's greater than to the left of -1, so it's going to be over here. So it's actually in our domain, so we can proceed. Okay. So that was just a nice little exercise in blue, but you know, it worked out, so we can move forward. So now let's look at what we're given. So this one says inverse secant of a -√2. That's going to be equal to some y, right? No, equal to some theta, some angle. Okay, because what this is saying with the original, we're saying secant of what angle gives us a -√2, right? So now, if we have secant of some angle equals a -√2, this doesn't really mean anything to me. So what I'm going to do is convert this to its reciprocal. I will convert it to cosine and work with that. So secant is 1 over cosine of theta, and that's going to be -√2. Then we flip both sides, and we'll get cosine of theta is going to be a -√2 by 2. Okay. So now, I know that I'm talking about 45 degrees from the unit circle, and cosine is going to be negative in quadrant 2. So quadrant 2, we're going from 90 to 180. So if we look at our inverse secant, we see that, okay, so it looks like we should be in quadrant 2. Okay, so our answer should be in quadrant 2, because cosine is negative, so the secant is going to be negative, and secant is going to be negative in quadrant 2. So we should be discussing quadrant 2. Okay. So then we said theta. So is 45 degrees, but we need to be 45 degrees away from the x-axis in quadrant 2. So for a secant, 90 to 180. So then we're just going to say 180 minus 45. That's going to be 140, so that's a 135 degrees, okay? And then we just convert the 135 to radians, and I think that's where that result comes from. Again, I know it's a little roundabout. You just have to do the best you can. Do 180 times divided by 180. So 3 pi by 4, and I think that's it, yeah. This is equal to 3 pi by 4. Okay, I just converted from degrees to radians. Okay? So just kind of, it's a video, so you can run it back and rewind and do all the things you need to do for it to sink in. Eventually you want to, be doing it on your own. You want to try to get to a level of proficiency to do it on your own. But so that's why we're doing videos, so that you can watch it over and over.